Okay, now sound. Okay, sound. Okay, thank you guys for letting me know. So here is the live class that we are going to talk today is about ROS messages. So I hope that you are eager to learn a lot about that. So I would like to say hello to all the people on the chat, starting with Lagan Kapoor and then Baurito TV. Okay, hello, how you doing? Nice surname or whatever it is. Li Liu, then John Leon, Gada Salim, hello, Divey Sign, Arkham, Aquil, Oscar, RB, hello, how you doing? I can see some names already from other live classes, but also I can see new names in there. So of course, all of you, you are welcome. You didn't have to start in previous live classes. You are welcome on any live class. So we are going to start right now and I'm going to tell you how does it work. So how do the live classes work? So what you have to do is to practice with me at the same time. And how are we going to do that? Well, because we have prepared a ROSject. It's a ROS project that contains all the material that we are going to see during this live class. So I'm going to share with you this ROSject and then you are going to open it. I'm going to show you how to do it, okay? So this ROSject is a specific ROS project that can be opened on a web browser. So when you click on this link, you are going to get a copy of the ROSject that I have created and then you are going to open it on your web browser. You don't need to install anything on your computer. That means that you can use a Mac, Linux, or Windows. So that's okay for the live class. You don't need any setup, just willing to learn, okay? So the process is that I'm going to show you my ROSject, I'm going to share with you, we are going to open it together, and then we are going to start doing. So you need to do at the same time as I am doing, okay? But in case that you get stuck, you have some problem, something, you can put your question on the chat. You see the chat that you are saying hello there, and then you can ask your question then, and I will be keeping an eye on the chat and trying to answer your questions as we go. So that's the purpose of this live class. It's like a real live class, you know, when you are at the university and you are with your teacher. So that's it. So maybe we'll have some interruptions from some of your colleagues. That's okay, no problem. The important thing is that all of you learn a lot. So you leave this live class with the sensation you have learned a lot and that you have profited this time in this live class, okay? So let's go, guys. And then let me share first my screen with you. So here we have here the screen. So this is the ROS Development Studio. That's the tool that we are going to use, okay? That's a tool that the Consort has created. And here we have the ROSject for the class of today, which is about ROS messages. So what I'm going to do is to share this ROSject with all of you. For that, I click here, then I copy the link, and then I'm going to paste it on the chat. Okay, so I'm going to the chat right now, and then here is the ROSject of today, and here it is the link. So what you can do right now is to click on the ROSject, on the link that I have posted on the chat. By clicking there, you can get a copy of this ROSject. So you are going to be redirected to the ROS Development Studio. Then you have to log in with your account. In case that you don't have one, create one free account. That's okay. And then you go straight into the page, so you will see the ROSject. Then you can open it, okay? So let me see on the chat if there is any problem up to this point. I can see that there was one guy, Ashish Chandok, that was having the problem of no sound, and Lagan is answering about reloading the stream. That's correct. Thank you, Lagan, for answering. And then Judin says, will I have access to this video after the live stream? Yes. So all the live classes, they do stay on YouTube, so you can come and watch them later. The only difference between the people that attend to the live class is that they get access to the ROSject. And the ROSject is, it's really good educational material for learning ROS. It has a lot of value. That's why we want to we give a prize, a reward for all of you who are attending here live to the class. And I can see that we have already 46. Then all of you are welcome. The late ones, you have to stay on the seats of the back of the room, but it's plenty of room there, so no problem. And please don't be shy. Ask your questions here. No stupid question is any question. So we are here to learn, okay? So don't feel shy and write your questions there. And in case that you are shy, then that's okay also. It's okay. The important thing is that you learn. Okay, so I think that everybody is trying to load already. So some of the advanced users already loading. So let me show you how to load for the guys who are new. Then once you have this ROSjet in your zone at the ROS Development Studio, maybe you will have not this amount of ROSjets, okay, because it's my account, actually the account of the company. So you have to press this button here, open. So press open and then press open again. And now the ROSjet is going to open for you. So then it's going to take some seconds, and then it depends on the amount of people loading. But yeah, so it's going to open in a few seconds. So do those steps and let me know if you can reach the following screen that is going to appear in a few seconds. Let me see. So yes, okay, still loading. Then I will take the chances to check the chat and also have some coffee. Well, in this case it's tea, but let me know if you have any problem, okay? If the steps are not clear. And in this case, starting to be loaded for Navid Mula already, very good. And in my case also loaded, it's here. So today we are going to use the ROSbot, which is from Usarion. That's why the environment for the ROS Development Studio has been set up for that company. In case that you are another company that builds robots and you would like to have your robots supported by the ROS Development Studio, let us know and we can set up the environment specifically for your robot. But anyway, so this is what you are going to get when it opens automatically. So this has opened the Jupyter Notebook, which contains the instructions in a Jupyter Notebook about the lesson that we are going to follow today, okay? So we are going to see all this material today, and this material is already for all of you for forever, so you can have it forever. Then in case that you get this closed by whatever the reason, so you can close this window by clicking on the cross here icon. Then you can reopen it manually any point in time, going to Tools here on the menu on the top, says Tools, and then select Jupyter Notebook. Okay, so it's going to open again the documentation. Okay, great. So this is in case that you close for whatever the reason, and don't feel that you cannot reach again the instructions, so because the instructions are very important in order to follow all these steps. Let me see on the chat, there are some questions. So Mo Taher says, thank you for this amazing education experience. My pleasure, Mo Taher, my pleasure. Will you make video about how to write code in Python using MoveBase, basically for dynamic window approach, global planner with a stereo camera? Okay, it's a very good suggestion. It's a very good suggestion. So let me think about that. Let me think when we can put that, but definitely I think it's a very good subject. So let me put it on the list of close future live classes. Then Lagan Kapoor says, Sir, where is the Barista Robot for coffee? Yeah, the Barista Robot, it's at the office, you know, and now we are confined at home, so I cannot go. The same way, I'm not having here my mug about ROS Developer, so I'm missing it. So the DB sign says, I am using ROS Melodic with Gazebo 9 locally. Will your step and explanations be same for me? Yes, it is. So what I'm explaining, what we are going to see here today, is the same for any version, any distribution of ROS, any distribution, because this is the core of ROS. That doesn't change with different distributions. And then, let me see. So Lagan is answering. Another question is a question, but in another way. Okay. So Sirajudin says, "Are you using ROS 1 or ROS 2?" ROS 1 here. You can see the configuration that we are using here on this on the top menu on the right hand side. Says Ubuntu 16 ROS Kinetic gazebo 7. This is the configuration that we are using here today. But you can create other ROSjects, other projects in the ROS Development Studio with different configurations. Okay, check the documentation. Then Gloria de Felix, new interface to ROS DS, red design. No. Okay, Gloria, nice to have you here again and to see you, even through the chat. This is the specific interface is configured specifically for Usarion, because we are using today a robot from Usarion. So let me show you very briefly, okay, very quickly. Here, if you go to the icon here of the wall, you can go back again to the list of all the ROSjects that we have, that you have, I mean, that the person has. So in my case, I have 255. Okay, so when I create a new ROSjet, so I start from a new one, I'm going to create a new one, I press this icon here, so I get this form to be filled. And then you can put here your name, blah, 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 and then choose a thumbnail. Then here is where you are going to indicate for which version of ROS, which distribution also. So you can create projects for Melodic, for ROS 2 Dashing, ROS 2 Eloquent, or ROS Kinetic. So you select this here. And also you can select a specific robot to program for. At present, we support those specifically. So for this ROSjet that we are using today, we have the ROSbot for ROS Kinetic, so from Usarion, so is the one that we are going to use that. But we can use the Gen 3 from Kinova, for example, or the Tiago from PAL Robotics, or the Summit XL by Robotics. So when you select one of those, then the environment that when you open the ROSjet will be set up according to the logo and colors of the corporation of that robot. So it's kind of feeling like you are working on that robot. Then if you are not going to program to any of those, just select no robot selected, and then you will have a standard interface look and feel. Okay, so let's go. Let's start, because we have a lot to do here today. Even if it's easy, but it's a lot of material. So mouse pointer is not shown. Oh, okay. Okay, I don't understand why this mouse pointer is not shown. Let me see if there is any. Okay, I cannot check that now. Sorry for that. I cannot do it without crashing the transmission. So let's continue now without this. I will check that later. So for about today, we are going to learn what are ROS messages and why so important. So why this? Basically because the ROS messages are like the blood of ROS. Is the blood that is moving through all the ROS nodes, all the ROS programs that are running inside the robot. So you're going to see in a minute. Then in order to understand the content here today, it is required that you know at least the basics of Linux, because we are going to do some commands there. Also the basics of Python and the basics of ROS also. In case that you don't have those knowledge, then please check those links there where I have put some courses that you can take in order to get those basics. And this is a ROSject already explained. So let's start by going and launching the simulation that we are going to use today. As I mentioned, is about the ROSbot. So the simulation is already included into this ROSjet. You can check the files here. Let me show you. Here you go to Tools, to the top menu where it says Tools. You press there, and then here you select the IDE option, and then a new window is going to appear. I'm going to put it here on the side, And here you can see that all my files can be seen now. So you can see that there are different workspaces here on this file explorer. And there is one that is called the simulation workspace. If you click in there, you will see it's a ROS workspace called simulation workspace. Then inside source, you can see that you have the ROSbot Usarion robot. So here all the packages related to the simulation. So that's already included inside these ROSjets. And then how do we launch it? Going to the top menu again, top menu where it says simulations. Here around the middle of the option. So simulations, click on simulations, and then on the window that appears, select the blue icon that says choose launch file. Then it will appear another window that says select the launch file. Here you have to select the one that is indicated in the ROSjet, that it's in the documentation is indicated. So you have to look for the ROSbot gazebo, then maze-wall.launch. So select that one and then press launch. And you will see that the new window appears with the loading of the simulation. And then after a few seconds, we'll have the simulation there running. Okay, so that's the first step, because we need a simulation and we need a robot that is publishing messages on topics, so we can start doing our tests. Yes, great. So let me see. Okay, so sorry, I think I launched the wrong file because it's a start wall maze, and I think I selected wall maze only. So I need to relaunch because I cannot see here the robot, so that means that I haven't launched the simulation that spawns the robot on the simulation, so no problem. Let's go to simulations again. Then here there is a yellow button that says change simulation. Just press there and then again choose launch file. So maze wall, yeah, that's maze wall, and it has to be start wall maze. So I'm going to select, oh, wait, here, okay, start wall maze, that's it. Okay, then you launch again, and then it's going to reload the simulation. So let me, while it is loading, so let me go to the chat a little bit. We should get something like this, okay? So let me see. And then Ashish says, please create live class on Kairos Robot. Mobile manipulators are becoming popular. Yes, that's right. That's right. Yeah, so, okay, very good suggestion. The problem is that it's difficult to do a live class in a short amount of time to teach something. It requires that the audience has a lot of knowledge already. Then Faisan says, there should be a video on Evening Flatland repository. Okay, I don't know what is that. Mehmet says, can you make a video of the transfer of what we draw in SolidWorks to Gazebo environment? Okay, so it's already done. So check our YouTube channel, this channel, and check. Just type on the magnifier on the search of YouTube, and you say transfer from SolidWorks to Gazebo. We already have done it. Very, very detailed one. It's a 1 hour something video. So. And Lagan Kapoor is answering that. Okay, let's go. Let's continue. So what about the messages? As I mentioned, the messages are the blood of ROS, and they are everywhere. So let's do one thing. So we have this simulation here running, as you can see, of the robot. So it's publishing on its topics and so on. So let's see, what do we have? Then for that, we are going to need, for this session today, to launch a terminal. Then the terminals, you can find them on the menu, on the top menu, where it says Tools. Go to Tools and then select Shell. On the menu, Tools, Shell. Okay, so we have here a terminal, Shell. And then let's do what the commands that are on the notebook, that is ROS Topic List. And we are going to see a lot of topics. You know what are topics, right? The topics are the channels through which the programs, the ROS programs, they are transferring information or getting information from other ROS nodes. So, for example, let's check, for example, the command bell topic, which is here. Okay, as in the, how do we check what is this topic about? With a very simple command, which is called ROS Topic space info space, then the name of the topic that we want to check is /cmd_bell. Then we get this information here on the screen that says, hey, the type is geometry messages /twist. What does it mean? That means that this is the important bit for today's class. So that what that means is that this topic, bell here, it's publishing information with messages of type twist. This is what it means. So what is a message then? Well, a message is just a data structure. It's a data structure in order to send information with a given structure from one node of ROS to another. So that's the message. The message is just the way that you organize the information. And then you can have different types of structures. So if I want to send velocity commands, then I can use a structure that contains inside the velocity commands. That's a twist. But if I want to get the, for example, the scan here, the scan is the laser data, then we are going to do the same command, ROS Topic info from /scan. So what we get now is that it says type sensor messages laser scan. Okay, so the scan topic is publishing messages of type laser scan. That's a different structure, of course. That makes sense because the velocity has some values, but the scans that have others. So the structure for these data should be different. So that's why those topics, they are publishing different types of messages. Then every topic has a message that is associated to it. Okay, and every topic has a different type of message. Well, it depends because it depends on the type of information. You can have different topics that have the same type of message, but the data that is transferred through it is different. For example, here we have the range F1, range FL. So let's check that one. So ROS Topic info range F1. Okay, so it's a topic that is publishing type range. Then there is an FR, so it's a range FR. So if we do the same command info, ROS Topic info range FR instead of FL, then we see that the type is the same. Yes, of course, they are two different topics that are publishing the same type. This is type, but the content will be different, of course, because this one is for the left range sensor and this is for the right. So it depends on what they are measuring. If the right is measuring 1 meter, is going to include here inside the range structure, is going to say 1 meter. And the left is detecting a closer obstacle, 0.5 meters, then it's going to see its range message is going to say 0.5. It's the same type even if the content is different. Okay, and then what about this thing that it says on the type? We can see here that it says sensor underscore messages. Here also says that. Then on the laser also says that. On the common bell it says something different. It says geometry messages. Well, that is the name of the ROS package that is defining this twist message. We are going to see in a minute how to define a message. But this is the package that is defining this twist. So the twist message is included inside the package geometry message. And the laser scan is defined inside the sensor messages. And the range range type of message is also defined inside the sensor messages. Okay, so those are the packages. Let's continue and you are going to see that. So one thing, as I mentioned, is the type of data structure. This is range, this was laser, this was twist. This is the type. And another thing is the content. Is the content of that is being published on there. So let's do a thing and let's observe, let's watch what is being published on the topic of odometry. So in order to watch what is being published, which messages are actually sent now, in real time, now, which messages are sent, we need to use the ROS Topic Echo command. ROS Topic Echo and then the name of the topic. Then let's do ROS Topic Echo, then the name of the odometry, and in order to not to over collapse the terminal, publishing a lot of data in there, let's put an option that is -n1. That means just publish one, you know, because the odometry topic is publishing at a very high frequency, so it's going to publish a lot of data there and it's going to collapse our terminal. Well, we are going to see nothing there. So then let's put -n1 and then you can see that one. Okay, that exception doesn't make sense to me. I don't know what is that. But anyway, so we can see here, here is the message. Remember, here is the the command that I have issued in order to see one message. And then you can see all this information here. Okay, so all this information is the data that is being sent of type odometry on the topic. So let me show you here. Okay, so yeah. So this is one single message with the structure of an odometry message that is being sent through that topic. And it provides in real time the current situation of the robot. If this is measuring, it's publishing the odometry, then what we can see is the odometry information here. Maybe it doesn't make any sense to you if you don't know what is the odometry, but basically we have here the position and the orientation of the robot in X, Y, Z terms, and the orientation in a quaternion term. So then also we have the covariance of those measures, and also the odometry also provides the current velocity of the robot, which is linear and angular, and both of them, they are very zero. Okay, so that's one content of odometry. Okay, so what is the difference between the content and the data structure? So let me show you. So if I want to see the structure of a specific message, then I had to use this command, which is called ROS Message Show, and then the name of the type of message. So let's see which one is the structure for the odometry. Okay. Here is for the twist, but I started with the odometry, so that's okay. So let's do one thing first. First, ROS Topic Info /odom. So I want to identify which one is the type of message of the odometry. Now I see that is odometry. Okay, now I want to see which one is the structure defined in this message. So how is all those fields? So which one are those fields composing this message? So I had to issue this command ROS MSG space show, and then the name of the message, odometry, with capital O, remember. So that's important. So now what it outputs is exactly the structure. That's all the fields that need to be filled by your program when it's publishing odometry data. And then you have all the structure. So you have to fill the sequence number, the time as a stamp, the frame ID, then the child frame, if there is any, then the position on X, Y, or Z. So you have to fill all that for every message that you are sending of type odometry. And that's exactly what we got here. And it's been filled by when we did the echo. So you can see it's a message that has been filled already. Okay, so that's important to understand, okay? The difference between the structure and the actual content of the message that is being done. So here you can see the structure of this odometry message here, and then we can see some information that is interesting here that I would like you to really understand in order to understand messages. First one. Here you have the name of the message. This is the full name of the message, but even with that, it will work. So that's the name of the message, and that's the package that has defined this message, the ROS package that has defined this type of message. Then we start with the definition of all the fields that compose this structure, that is the odometry. And then we have a header. So there is a field that is called header, which is of type std message / header capital. So there is a field inside this structure that is called header that is of this type. Then this header, it is composed of several other parts. So in concrete, it has 3 parts. So how do I know that this header type of message is composed of 3 parts? Because I can see this indentation here. So when you see one indentation, you can understand that this indentation means that those components with the same indentation belong to the superior type of message. Okay, so if we go to the top here to the other messages, okay, so we didn't see. Let me go here to the notebook. So if we come here to the notebook, you can see that this type it's even easier. So let's do the twist then. So let me repeat the command: ROS Message Show twist. So you can see here again, this is the package that defines the message, this is the name of the message, and this is the structure of the message. Then this message has a part which is linear. The twist only contains linear, which is a vector 3 message. And then this linear has 3 components: a float x, float y, and float z. That's correct, because for the linear speed. And then there is another component which is angular, which also has 3 different components. So all those, you can see that they belong to the previous class. So the indentation is very, very important. Then what do I have here? Understand the difference between the message structure and the message content, already explained. And then I have also done the odometry message, and also explain about the package navigation message. Okay, so let me know if you have any question. Okay, there. Then what else? So I have been saying that the twist message, for example, this twist message here, is being defined inside the geometry messages package. Okay, so how it is defined, so how does it work, this definition? Yeah, very simple. Let's go to the geometry messages package and see what it happens there. Okay, so how do we go to a package in ROS? So we say ROS CD and then the name of the package. It's geometry _ MSGS. Now, let me put it here. Here. You can see better, I think. So there in this package, if I do an ls, I'm going to see a directory, special directory, which is called MSG. This is the directory that contains the definition of the message. So if I go inside the MSG and do an ls here, you can see many files with MSG extension. Those are all type of messages that have been defined in the geometry messages package. And here we can see our twist. So here there is the twist. Okay, so let's see what is the content of the twist. So if we do, how can we check the content of a file in Linux? Is with cat command. Cat and then the name of the file, twist.msg. Okay, so not so much. Not so much. Then I'm going to explain you, but let me see, because there is a question from Lagan that says, I have one question about tutorial. If we teach people with easy robots like TurtleSim, is not a better option? Well, yeah, it depends. It depends. So it depends how you structure your teaching. Okay, for me, it's more interesting to have a 3D simulator because it's like having the real robot there for me. And I think that it's closer to teaching the people about the robot, you know. It depends on you, and also it depends on your equipment. It depends on how you structure your teaching. So it depends. Okay, so we were on this question, on this point, that we saw what a twist message file it's containing, and you can see that there is two parts only, linear and angular. So only that, and linear is of type vector 3, and angular is of type vector 3 also. Okay, so how does this compare with what we have seen here in ROS Message Show? So, I mean, I cannot see this structure here. I cannot see here, I see a lot of components. I can see here the linear vector 3 and angular, but what about all these components? Well, because in order to simplify, when you create a message file, you don't need to specify all the subcomponents for each one. So if you know that there exists a vector 3 message that already contains those components, then you can just specify in this way. So you can say, I have a linear variable in my structure, a linear value that is of this type. So I know that linear contains 3 components and angular the same. That means that whenever you define a message type, you can reuse this type into other types of messages. So it's kind of a dependency, you know, when you depend on other messages. So that's exactly what they are doing here. They are depending on the vector 3 message, which is already defined into the vector is in geometry messages package. So it has to be here and it's here. So here it is. So if we do a cat of the vector 3 dot message, then you can see, apart from those comments, that this is just information, then you can see finally the 3 types, the float, 64, X, Y, and Z. Okay, so that's the final type. So it's a type that is already defined by ROS itself. Okay, so far so good. Let me know if you have any question. Then, let me see, here I have my the notebook that you can use as a structure. So maybe I'm not following exactly the structure, it's just for notes, you know, so you have all the information there also. Okay, so what the next point is about already existing messages. So how do I know which already existing messages? Well, you can see that ROS already provides on the standard installation common message package, the standard messages package, the geometry messages package, and the navigation messages package. So all those packages are defining a lot of messages. Then you should go to all of them and then check which types they are creating, they are defining. So you will see when you go to a package that there is a MSG directory, as you saw here. There is an MSG directory, and then inside there you will see that there is a lot of messages. For example, let's go to common messages. If we go to ROS CD common messages, then there is do an ls, then I can see, oh, and common messages, why is not, there is no message package? Okay, so I don't know why. Now I don't remember why. Okay, check. We have to check this, why it doesn't have a message directory common, and which types. I think it's because it contains the basic ones, so it's just the basic code for the others. So it's just the basic types that we are going to see here. Yeah, I think it's just for that. So that doesn't require to have a message type because it's just code. Yeah, I think, but I'm not sure, okay? So I'm not sure, so we have to check. Then let's try with another one. For example, standard messages, std msgs. Then we check here. Here we have our MSG directory, ls msg, and then you can see all those types that are defined in there. And actually, so it's in standard messages that we have the initial types. Okay, let me check, for example, the float 32 dot message. Oh, okay, msg slash, okay, it's a float type, a basic type. Okay, yeah, so exactly, so those types, I think that these ones are the ones that are defined in the common messages, and then in the standard messages is where we have the official messages for each one of those types, basic types. So the basic types that you can, with which you can create any message are these ones here. Are just basic, very, very basic, the typical in any language, like the Boolean, the integers, different types of integers, and different types of floats, then a string, a time, and a duration. This is for times in ROS, how they are managed. So you can use those there. So those are the basic types that are at the core of most of the messages that are defined already in ROS, that you can find in ROS. Like for example here in the vector 3D we have the float 64 that we have here. Okay. Then let's see, let's go to the next thing. Is about how you can create your own messages. So there are a lot of messages already provided, as I mentioned to you, in ROS, but you can create your own messages. And before that, let me answer a question from Ashish that says, how to get a navigation message from robot odometry topic and get the XY pose. Okay, so for that, I don't know what you mean. You mean by using a Python program, so, or a C++ program. Then you have to subscribe to the odometry topic, and then when you subscribe, you will have a callback function. Then this callback function is going to capture all the published data in the odometry topic. And then once you have this odometry topic capture, you have this message that you have received, then you receive the message as a Python structure of data. And then it's very easy to get into the data of a message, because you only need to do, for example, if you receive your data into a variable that is called data, for example, and is an odometry one, let's see the structure of the odometry. So you would like to access the X and Y position. Then you are receiving a message of type odometry. Then on your callback, you get all this information, but with the field value. So actually you will receive all this information here. Okay, so you receive all this in your callback. And you receive all that into a Python structure. That means that you can get and go, you can go name by name of the structure until you reach the variable name. So if you want to get the X and Y, that would mean that you need to go from the structure that contains everything, let's call it that data. It will be data dot pose again, dot position, and then dot X. That will give you this value. Then again, if you want to access to the Y value, then you have to say data.pose.position.y. That will lead you to this value here. Okay, so if you want to do it here from a topic, for example, directly on the screen, then you can do like this. For example, ROS Topic Echo of the odometry, and then you have to put a pipe and then grep by X, for example, X dot, 2 dots. Then by doing this, you are going to get the X. The problem is that there are a couple of X or 4X on your odometry. There is one X for the linear, for the angular, for the, what else? For the position, for the orientation. So you have 4 of them. Okay, so but you can identify, that's a way of doing it. Or yeah, you can do it grep instead of that, then grep for position, and then after 4, something like that. I think it's like that. No, after 4. How was this option? I don't remember. After 4. No, okay. Grep. I don't remember that option, which is about. Let me see. After 4. No, it was like this. Okay, I don't remember. There is an option in grep that you can specify. Okay, that's it. Yeah. So you can specify how many lines after what you find you are going to get. So in this case, it's 4 steps. So you get position and then X, Y, and Z. So that's it. After, and there is also before 0. Well, you play with those options, that's not important. Then there is a Bensak that says, could you please explain ROS services? Not right now, because it's not the subject of today, but you can check our channel for other videos explaining about services. So let's go and let's finish by creating our own message. Okay, that's the end of the system. And then when all the types that are provided already by ROS or by other people that they have created messages, packages, messages, and they are created so you can use them. So in case that you don't find the one that you would like to use and you need to create another one, then you can create your own messages. But it's very important that you only create messages when you are sure that it doesn't exist, because it's a lot of problems that you need to solve. Well, I mean, it's a complete complexification of the situation that you don't need to do if it's already done, and you spend some more time trying to find the already existing. Also, that will make easier your interchange between your package, between your code and other code from other people. So it's better that you don't create new types unless you really necessary, you need to do it. So in this case, we are going to create a message, a very simple message, which it's called H, is going to contain the amount of time that in years, months, and days that your ROS program has been running. Okay, so let's do that. And for that, we are going to create a package. We need to create a package in there. Then for that, let's go to our area. If you type cd, then you are going to your home directory. You can do an ls and see the different types of workspaces. And then let's go to the Catkin workspace, cd Catkin workspace / source, because we are going to create a package there that is going to contain our code. For that, you need to do Catkin create, create pkg. Then the name of the package is going to be my message pkg, my message package, for example. And that depends on ROS pi. So you indicate there ROS pi also. By using this command, it's going to create for us a package that depends on ROS pi. Okay, so now if we go to the IDE that I opened here, and I'm going to close the simulation workspace and open the Catkin workspace source, then I can see my package being created. Okay? Okay, so far so good. Then inside there, let's use the IDE. If you don't remember how to open the IDE, go to the Tools menu on the top bar, Tools, and select IDE. That's it. Then we have here the my message package. So the thing that we need to do is to create a directory there. We can use the IDE to create the directory by doing a right click on the my message package directory, then new folder, and then indicate MSG. Remember that all the messages, they are stored into an MSG directory. So we have here the MSG, and now inside there, let's create another file. So you select the MSG and then right click, new file, and we are going to call here create the name of our file that contains the actual message, and it has to be h.msg. And then as you have seen, I have put the A in capital. So that's the convention in messages. So in messages, the type has to start with a capital letter. So that's the H. Then press OK. So now here we have our H, which is open automatically. And then let's put this content that you can see here on the side of the notebook. Basically the three components. So I'm going to copy and paste here. So as I mentioned, our message contains three parts in the structure. One is years, that is a float 32, months again, and days again. So very, very, very basic, okay? So now we have created this message, but still the message is not available to any program that would like to use it. For example, your program that you would like to compute the amount of time. So in order to do that, we need to compile this package in order to generate from this text file, generate all the Python and C++ structures necessary to use this message into a real program. Okay, because this is just text. You cannot use this into a text, into a Python program, for example. So we need to compile the package and tell the package to generate the messages. So that's what we are going to do right now. So for that, we need to open the CMake list of the package. So you can see that the CMake list is here. Press here on the CMake list, and here you have. So we have to modify in three places. I have written them here just to not to confused, so you can come later and check it later. So the first one is the find package. So we have to say that it has to get the standard messages and also the package about message generation. So we have to add those two here in the find package section. You can see find package, okay? After ROS pi, I'm going to put std.msgs, and then also message generation. You can see that the system is already suggesting that those. So great. Then this is the first thing that you need to add in order to generate those messages, your message. Then the next thing is that we have to uncomment the add message files. So this section here in the CMake list, we had to check it down a little bit. So here it is, add message files. As you can see, everything is commented. So we need to uncomment this, the add message file, then the files in capital also, and then don't uncomment those message one. Okay, actually I'm going to remove them because they can be confusing. So I'm going to remove that. Those are just examples. Okay, then remember to uncomment this final closing bracket. It's not a bracket, I don't know how to say. Well, so remember to uncomment that one also. So this section is open here and close here. And then below the files, you need to include your message file that you want to actually compile. Okay, so it's the one that we have included into our message directory. It's called h.msg. So that's a file that we want to add as a message. And finally, we need to generate the dependencies. So let's go down, and also here it is already commented, and then you can uncomment all of them. Generate dependencies, standard messages, and the bracket, the closing bracket. Okay, so that's all that needs to be modified on the parentheses, says Donna. Okay, thank you very much, Donna. Parentheses, yeah, something like that. And Thomas, I can see on the chat that Thomas has written the proper command ROS Topic Echo, Adam grep position -A1. Okay, -A1. Okay, thank you, Thomas. Then, what else? Then we need to modify the packagexml. Also, in order to include those two dependencies, one for building the message generation and also when executing the message runtime. So for that, we need to go to the packagexml, which is here, open it, and then go to the bottom where all the building and execution dependencies are specified, and add those here. It's just the message generation and message runtime that needs to be loaded. So you can copy and paste here. Okay, so we have, well, indentation is not necessary here, but let's put it in order to make it prettier. Great, so we have everything. And now let's compile this. Let's compile. And for this, so this is automatically saved. So the only thing that we need to go is to go to the compilation. Remember that in order to compile, we cannot compile directly here on the source directory. So we need to go to the Catkin workspace. So do a cd, 2 dots, and then here you can do the Catkin make. Catkin_make. And then this is going to compile our package with our messages. So what is going to happen is that actually what we have created here is to create another package that defines messages in the same way as we have seen here previously in all those other packages. Okay, so it's usually programmers, ROS developers, they try to use the ones that do exist, but sometimes you are defining some other information that you need to process, that you need to publish and doesn't exist, that message, then that's the procedure that you have to say, that you have to do. Okay, so in my case, the package has been created and compiled without a problem. So if I do, for example, a ROS message of the age, what is going to happen? So nothing. Probably is going to say nothing. Okay, yeah, it's okay. So that's because I had previously tested, but it should give you an error. In your case, well, in your case, neither, because you already had also the the package. Well, what I wanted to do an exercise that is, in order to make your new message available, you need to do a source. Okay, so the thing is that I had already done this and it was on the build already, so that's why it does exist. It knows. So you had to remember to do the source. Okay, source devel setup.bash. So by doing this, then you are recognizing all the amount or all the new messages that have been created. So now any other option, any command, for example, ROS Message Show should work, or you can use that into a program and start publishing your H messages. Then what else? So before going to the chat for questions, let me tell you that we have seen here at present only one type of message, which is the messages that are used for topics, for sending information through topics. But ROS also provides messages for services and also provides messages for actions. Both of them are quite more complex than the messages for topics that we have seen. The messages for topics are the easiest ones, and you should understand them in order to understand the other ones. So we are not going to go into those, and if you don't know what are services or actions, don't worry, that's not the topic of today. So that's not the subject of today. So we are going to leave here for that. But I think that with all this material, you already know and have a vision of how messages work and how you can manage yourself when you have problems with messages. So before going to the chat, I would like to give you some homework, should you accept to complete it, of course. The challenge is that you modify this program, this package, so you create a Python file inside that it's a node that uses the H message and publishes into a topic called H the amount of time in years, months, and days since your program has been started. Okay, so that's the homework. Then you should try to do that at home or now after the class, and let me know if you have any problem. I will be happy to answer your questions or put your comments on the video below if something doesn't work. So I will be keeping an eye, okay, and answering your questions. And now let's go. And then I have here the last comment says from Donna that she was telling me about the parentheses. And she says, fuck no, I don't do homework. Okay. Okay, this is just in case that you would like to. It's not mandatory, of course. It's just for your own, if you don't know how to progress, how to keep moving, so then that was just a suggestion, okay? Don't worry about that. Then Donna Adams says, remember also, you are in control of the computer. What does it mean, that? Okay, I don't know. Then Oscar says, if we create the package indicating it depends on standard messages and message generation too, will these be included in our CMake list automatically? Yes, that is right. They will. And Donna says, yes, it's very pretty. Okay, Donna is just kidding. Okay, very good. And then just before finishing, so let me give you ask you for support to our work. If you like the video, please give us a thumbs up also. And then how can you support us? Well, you can support us by subscribing to our online academy, where we teach ROS and many related subjects to ROS, including about deep learning, autonomous cars, how to build your ROS robot from zero, and many ROS 2 also. So we have many courses here in this academy. So if you want to support us, subscribe and take one of the courses there. So you can have a look later and you will see that there are many interesting courses. For example, to understand TF, finally, understand TF. Okay. Then if that's too expensive for you or you are not in the mood, then you can buy one of the ROS developers t-shirts or mugs that we have. So you have here a link to Teespring where you can find those merchandising. I have one, as you can see, I have one of the t-shirts, and on the office is my mug about I'm a ROS developer. At home here I don't have one. And finally, if nothing of that is okay for you, you don't like it, don't worry, but give us a like and subscribe to our channel. That's for free. So that will be really appreciated, and then will help us improve our the next live classes and so on, all the subjects. So I don't know if there is. Okay, another question. Then here is from Lagan, says, where is message runtime in CMake list? So message runtime is not in CMake list because it's not for compilation, it's for runtime. It's for when it's a library that is loaded when you are executing a program, a ROS node that uses a message that you have defined there. So that's why it's not in the CMake list. Then Botman says, Ricardo, what do you think about robotics fighting Corona? Okay, so I don't know how robots can fight Corona. Sorry, I don't know. Is that a news or something like that? So I don't know about that. Sorry, and I don't understand very well how we can fight Corona. Fight really to reduce the amount of virus that, or the people that is affected. I don't know. I think it's I should know more details about that, okay, about this initiative. That's an initiative, but it sounds like trying to use something that doesn't fit to the problem, but I don't know. It depends on what is the context, okay, of this proposal. So here, then Dominic Novat says, great live class, thanks Ricardo. Okay, Dominic Novat, it's a pleasure. I didn't know that you were here. So Dominic, for all of you that are there, Dominic is the creator of the ROSbot that we have seen there. And he is the CEO of the Usarion company, the one that builds those robots and sells the robots. Amazing robot, by the way. So thank you, Dominic. Then Botman says, can you teach how to make healthcare robotics? Oh, okay. So in the healthcare robotics section, as a way for providing some stuff to the people that is ill already. So in order to prevent that the people that is taking care of the sick people at the hospitals, they don't get sick themselves. That could be a solution. The problem I can see there is that I don't know, those robots are very limited in the amount of things that they can do. I don't know exactly what those sick people they do exactly require in terms of care. So I don't know. They can bring, for example, the food there. They can bring the pills, but some things more complex, robots at present, they cannot do it. So I don't know. Then related to your question, it's about, can you teach how to make healthcare robotics? Okay, I don't know. It depends on which skills you would like to include into those healthcare robots. I think will become useful in the future. Of course they will, but still we need to improve the skills of the robots. So our robots really, they are a little bit depressing in terms of the things that they can do. We are still very limited. That's why we need you, ROS developers, people of the world, the new generations that are there to come and help on those problems, because they are really difficult problems to do. Really useful tasks. I mean, cleaning, but really cleaning. I mean, taking all the stuff that is around here, that providing the food, for example, but providing to the user themselves, so feed also the food. That's very difficult problems that have no solution now. We can have robots that move from one side to another and transport the material from one side to another, one place to another, but nothing more, really. That works in a real environment, nothing more. Then I have here a lot of questions. Then let me see here. Okay, so I cannot download here. Let me see. Okay. So then Nice Dominique, Lagan says reduced, Botman says this sounds like an opportunity for ROS developers. Definitely, yes. It's a tough place. I mean, still we need a lot of improvements in terms of research. So first, the basic research still doesn't exist. So the robots in the lab, in very, very controlled situations, they cannot do those tasks yet. So still, it's required a lot of base knowledge that we still don't have. And then implement this into a robot. Then, wow. And then, what will be the next live class beyond? So the next live class, it was supposed to be the ROSbot, using ROSbot robot with ROS 2, but I don't think, but using the real one, but I think that we are going to change. Still we have to decide, because the real robot is at the office and we cannot go there. So we cannot move because of the status in Spain, in Barcelona, in concrete, where I am. So I don't know, maybe we'll try to do it with a simulation, maybe, I don't know. Still we have to discuss that. But please subscribe to our channel, then press the bell. If you press the bell, you will be notified of any new advance, any new news that we are putting. So any new live class that we generate and we publish there for the next week, you will be notified. So you will know in advance. Then what else? You need, Giorgio, Gada Salem says, need continuous live classes and courses. That's great. So we have a lot of videos in our YouTube channel. Go there and check them. So we have some live classes in plain list. So you can use this list in order to follow those live classes. But also we have up to 800 videos there. So you have a lot, plenty. And Gloria says the Construct Discourse group is where this community is meeting offline to talk about the Construct courses and everything about ROS. So that's right, Gloria. So you can talk there about anything related to ROS that you have. So let me put the link on the comments of this video. So the link to the Discord channel. And there is a lot of hundreds of people already there because of the last week. I don't know if you know, but last week, with the Construct, we did a series of 2 hours classes every day of the week. That was an amazing week. We had so many problems, but we solved them, and then people could learn a lot. We were hundreds of people on those live classes. So that's when we published the Discourse channel, where all the ROS developers and people wanting to become a ROS developers can go there and talk to the other people that are trying to solve the ROS problems and so on, get ideas, get collaborations between you. That would be great. And then Man says, lead the way for the next generation of ROS developers. Okay, yeah, that will be our honor to do that. So that's what we are trying to do also here with those live classes and all the material that we provide as for the channel. Then Donna says, I think he's talking nanorobotics where thousands of them get injected and and the bloodstream. Okay, that's another thing. That's another type of, that's a real fight. That's a fight. Was thinking about something like that, but didn't make sense. That is many, many years away. Nanorobots that fight the viruses, this is science fiction at present. Sorry guys, sorry to say that. But that doesn't mean that you cannot decide to jump into that subject and say, okay, then it's me that is going to provide a solution to that problem. So I'm going to be the one that generates the first nanorobots that fight viruses. That would be awesome. That would be awesome. But it's a long journey yet to reach that. Then if you feel like doing that, that would be great. Awesome. So let me tell you that in my case, for example, I think that the robots that we have today, they are stupid. They don't understand what they are doing. Even if they do something very well, they really don't understand what they are doing. That's why if you change something very small in the system, then the robot gets completely, that doesn't know what to do. You can see that in many examples of the deep learning. And actually you can see a lot of examples in this book that I have here, for example. It's about rebooting AI. It's okay, the book, it's okay. But what is interesting is that it's showing how to create those, those situations in which the robots or the intelligent system, because this is for intelligent systems in general, they don't understand what they are doing. So my interest is into creating robots that really understand what they are doing. Even if it's simpler things, but they do understand, and that's very huge. It's very far yet, those things. But in any way, I mean, I don't feel like I'm going to leave that dream to generate this kind of robot. Okay, so the same for you. Is if that's nano robot is very far, but if you feel like, go for it. It really, that's what we need. People that has those ambitions and try. That's a way to improve our world. Then what else do we have here? I think he's talking. Yeah. So that I saw. I don't have the CMake list. Thomas says he doesn't have the CMake list in Calculating Workspace. Thomas, you are watching it not in the correct place. Let me go quick. Even if very late, but let me do those things for you people, because you deserve that. You are the best, so you deserve that. So that was Thomas Peyrukain. So Thomas, this CMake list, check it out. It's inside your My Message package. It's not outside. So if I close this My Message package, you can see that the CMake list disappears. So it's inside there. It's inside this My Message package. But if you are in the Calculating Workspace, then source, you cannot find the CMake list there. Hope that solves your problem. The Donman says, thank you, Ricardo. We'll get back to studying. Great, go for it. Lagan says, anyone have remotely work for ROS developer? Okay, go there for this. And then here is a message from Gabriel says, do you have videos with UR3? Yes, definitely. Okay, let me see if I can change to the camera. So yeah, so we have videos with UR3. Actually, there are ROS jets with UR3. So if you go here to the ROS Development Studio, then you go here to the list of ROS jets in this icon that is a wall. In the top menu, there is on the right side, there is a wall icon. Then you press there, you are going to get into an area where so here in this area, you can search for public ROS jets. So you can try to search for UR3 and see what happens. And here you can see that some other people, they have been doing tests. So you can open those ROS jets, or you can copy and clone for you and get a copy in your area and try to see what is. And actually, I think that if you search for universal, you will find more, I'm sure. Okay, yeah, you can see here many projects with Universal Robot. UR5 also, Shadow Robot, Shadow Robot Smart Grasping, well, many copies, okay? But remember that there are many thousands. If you go to public ROS jets here on the left-hand side of the screen, you're going to see there are 37 public ROS jets. 37 public ROS jets here, so it's very likely that you are going to find what you are looking for in there, already made by somebody else. Let me see. Gloria says, I'm working on a telepresence robot for the X Prize challenge. If anyone is interested, please contact me. Yes, Okay, great, amazing. I would like to know about your experience, Gloria. Maybe I can interview you for the ROS Developers Podcast and then you explain us your experience. I'll leave that there. She says, what is an actual cost of robotic Kairos with UR5? Oh, I don't know, so you should ask them, but it should be around 50,000 euros, I think, or even more, 50,000, yeah. Then let's see, what else? Okay, Botman says he's inspired, very well. And then let me see, the Felix, so you are talking between you. And then Lagan Kapoor says, what's the name of the IDE we are using on ROSDS? It's called Teya. Then Navid Mula says, sir, did you read my message? Sorry, maybe I'm mistaken. So I jumped through it. Sorry, let me see. Maybe I didn't see it, sorry. Thank you, sir. Thank you, sir, for teaching. Okay, it's my pleasure, Navid, but I cannot see your message. Where is your message? Sorry, Navid didn't. Then Donna says, many thanks for sharing your work. Yes, our pleasure, always. So, Navid, please let me know about your message, which message it is. I will be happy to answer, of course. And guys, we are going to leave here. Stay safe, okay? That's the most important thing right now, but don't waste your time. Then keep doing like you are doing right now. You are doing great. So keep learning. If it is ROS, great. Robotics, great. Artificial intelligence, all those related subjects, great. And go to your dreams. So fight for them. So don't waste your time. Not too much on Netflix, okay? So see you next week with another live class. I will let you know which one it is. Okay, so thank you very much. Bye bye, guys.